So section 4.5 is where we start putting all things together from chapter 4. We start solving exponential and logarithmic equations. Now, this is an example of an exponential equation. You've got a variable in the exponent. What I would suggest in terms of solving this one is that you take the log base 8 on both sides. Notice you've got 8 to some power that involves x, and you've only got x on one side. So if I take log base 8, I can do this a couple ways. I can take this out in front, and then log base 8 of 8. Well, what power of 8 gives you 8? The first power. Or I could just go directly from here to here, because these two are inverse functions of each other. They cancel each other out, and they just give you the exponent. One way or another, you can get down to this line right here. And from there, to solve for x, since I got a negative x, I'm going to make it positive by moving it to the other side. It changes signs when it changes sides. This, I'll move to the left-hand side. That way I have x all by itself. And here's my answer. Nice. And you can calculate log base 8 either using Desmos or your graphing calculator. The important thing to see here is that in this example, I only had the variable on one side. If you have the variable on two sides, that's going to change our little plan of attack. So here, yeah, you could do log base 5 or log base 7. You can't take log base 5 on one side and log base 7 on the other side. It doesn't work that way. You have to take the log of the same base. And for whatever reason, I just always use log base 10 on both sides. So for instance, on the left-hand side, when I take the logs, I'm going to use my properties of exponents, and this term is going to come out in front. Likewise, on the right-hand side, I'll use our power rule, aka our parachute rule, and that term will come out in front. So it'll look something like this. I'll have a 7x plus 1 here, and an x minus 5 here. Okay, well, unfortunately, I've got x on both sides. So to kind of start getting that cleaned up, I can distribute this log 5 to both terms here and distribute the log 7 to both terms here. That leaves me with, x's on both sides and constants on both sides. So what I'll do is I'll move this term over to the left-hand side, and I'll move this term over to the right-hand side. Now again, when it changes sides, it's going to change signs. So this is going to come over here as a negative x log 7. This is going to come over here as a negative log of 5. So that's going to look like this. Now, in this one, I've got x's here and here. I need to get the x by itself. So what am I going to do? Well, I'll factor out that x, and it leaves behind this mess. Equals the right-hand side. The right-hand side didn't change. Now all I have is x times a number, so to get rid of that number, I'll divide both sides by that number and end up with this. And that's your solution. Now if you wanted to check that, you can. It's not too hard. I would use the alpha and y equals option, and then the first one there to do a fraction like this. And when it's all said and done, after you type in this answer, you can use the keystrokes that I have right here to copy that work. If you hit the store key and X, you can check it. Because the left-hand side of the equation was 5 raised to the 7x plus 1. And it should give me some big ugly number, actually a really small ugly number. And then 7 raised to the x minus 5 should also give me that same ugly number. And it does. So you can feel pretty confident in your solution at that point. Let's keep going. So those were a couple exponential equations. You could also be given some logarithmic equations. And the couple that we're going to solve here show you a little bit of contrast. So in this one, everything has a log. So all these terms are part of logs, and what that allows me to do is allows me to use my product rule to bring those together here. So log of a product is the sum of the logs. I just use that in reverse. Same thing here. Let's distribute the 8. That's going to be 8x minus 40. But this is what I wanted. That is, log of something equals log of something else. And now I can get rid of the logs. Let's jump on down here. This is what I expect to see on your test. If you want an extra credit point, then maybe you'll show me the step that allows me to get here, the missing step. And that'd be, I'm going to exponentiate both sides with a base of 5. So it's going to be 5 raised to the log base 5 of 6x, and 5 raised to the log base 5 of 8x minus 40. These operations cancel, so I'm just left with the 6x and the 8x minus 40. The rest is pretty simple. Subtract 6x from both sides to finish solving. You get a little linear equation here that gives you x equal 20. Quick reminder, you have to check to make sure that if you put this into your equation, it doesn't create the log of a negative number. It's not that a negative number can't be the solution, you just can't have the log of a negative number. Going back to our exponential equations. This one's a Webassign problem. I was a little surprised to see it there, but it reminds me of the stuff that we did in Math 1150. This equation is quadratic in form. And you can tell it's quadratic in form because the first exponent is twice the middle exponent. And that allows me to make a quick substitution. I'm just going to let u equal that middle term. And then automatically u squared is that term. This is a lot friendlier to solve. We solved that in Math 1100 and 1150. You factor, you set each term equal to 0, and you solve. But that's a solution for u. You want a solution for x. So let's remind ourselves that u is really taking the place of e to the x. And to solve here, these are just quick little exponential equations. You can take the log on both sides. And on the left-hand side, ln of e to the x, well, those things just cancel each other out. That's because this is really, let me remind you, ln of x equals log base e of x. So this is really log base e of e to the x. That's why it cancels down to x. And that'd be all well and good, except this one doesn't work as a solution. And let's see why not. You can see it on Desmos. You've got y equals e to the x. That's one function. We want to see where it crosses the line of 4, and it does so right here at ln of 4. ln of 4 is about 1.386. Perfect. But what if I needed e to the x to equal -3? Well, I'm looking to see where those two lines cross each other. And if I put in the line y equal -3, I think you're going to have a hard time finding a place where those two lines cross each other. They don't. And it's a reminder in a different way that you can't take the log of a negative number. So we'd have to throw that solution out. The only solution is x equal ln of 4. Couple more. This is a different type of log equation. If you're given this, I'd probably start by rewriting it as log base e of 9 plus x equals 3. Because I don't have logs on both sides, I'm going to approach this differently. instead of saying log of something equals log of something else, what I can do is I can rewrite this equivalently using exponents. E to that power equals this. So that'll give me e cubed equals 9 plus x. And if I subtract 9 from both sides, that's my answer. Now that's a nice exact answer, and unless Webassign is asking you for, an approximate answer, just type in e cubed minus 9 equals x, and that's your answer. Now, one where they are going to ask for an approximate answer is this last one. E to the x squared minus 8 equals x cubed minus x. So again, what we'll do is we'll do this by graphing. I'll let y equal the left-hand side and y equal the right-hand side, and graph both of those. So let's shut these off. And what am I looking for? Well, I'm looking for the points of intersection. And there's 2 of them. One here and one here. You're going to give the x values, and you're going to round that to so many decimal places. If they want you to round to 4 decimal places, you're going to have to do this on a graphing calculator to get that extra digit. Even here, sometimes this gets rounded, and you have to be careful about rounding a rounded number. If they ask you for, say, 2 digits of accuracy, you might accidentally end up rounding the wrong way. But that's going to be rare if you're solving these kind of things with Desmos. So that'll do it. Hope that you rock on this section.